Let's talk about the problems at the bottom of the page. So I've identified three sets of problems I'd like to do together, and these involve just a little more detective work in terms of figuring out what atoms you're dealing with on the periodic table, but they are really not much different from the top of the page. So we'll start with 17 and 18, and of course you should start with the neutral parent. So that is definitely number 17. Now I know that because problem 18 shows a question mark raised to a question mark. That raised question mark in the exponent position, that's where the ionic charge is. So your job is to figure out all the question marks and to complete the electron shell diagrams that in some cases I've started for you. So starting with 17, the first thing I need to do is figure out what atom is this. So I see that there's 3 shells and there's 3 electrons in the outermost shell. So I'm going to go to my table, and the first thing I'm going to do is I'm going to go to group 3. Because I see that there's 3 outermost electrons. So that means that of the 100 or so elements on the table, I'm now down to just a handful. It's got to be one of these because these all have 3 outer electrons. The other thing that I realize is that it's in period 3 because there's 3 energy levels. Now, folks, please be careful. It's very easy for students to miss the first period. The first period on the table includes hydrogen and helium. The second period is boron here, and the third period is here. So my two locations, my periods and my groups here, intersect on one box, and that box, of course, is aluminum. So I've identified this atom as aluminum. So now what I know is that this question mark is aluminum, and this question mark is aluminum. But I need to finish the neutral parent. So this is a 2, and this is an 8. So now 17 is done, I need to work on 18. Well, at this point, you already have a label table. So let's face it, you could look at your label table, find aluminum, read up to the top, it's group number 3. It also forms a positive 3 ion, and in that way, label the ion here as positive 3. Or you could make the analysis and consider the two possibilities and figure out again what the ionic charge should be and write it in for that reason. Honestly, it doesn't matter. Whatever you do, you should realize that you need to end up with only 10 electrons and that this outer shell is now gone. Remember, a shell with no electrons is not a shell. Why did I print that shell on the page? Why did I leave it there if I knew you were just going to cross it off? And I did that because I'm willing to give some hints, but there's a limit. To my thinking, if I had removed that shell, that would have been me screaming that this is a cation, right? Because cations lose the outer shell. So I left that there for you to cross off. And now 18 is done. Well, let's move on to the next set. 19 and 20. So number 20, I see that it's in period 4, group 5. So on the table, group 5, period 1, 2, 3, 4. It's arsenic, As. So that means that this is arsenic and this is arsenic. You should finish the diagram and then either use that diagram to figure out the ion or use the labeling on your periodic table to figure out the ion. Either way, this is a negative 3. This is now 2, 8, 18, and 8. Now, of course, this is different from the last example because this was an anion. Negative ions form by filling the outer shell. Positive ions form by losing the outer shell and forming a new outer shell. Now, this just leaves the last set that I'd like to do together, 23 and 24. And sometimes students are a little trepidatious about this because they feel I didn't give them enough information. But look at the two choices, right? 23 is a negative ion and 24 is a positive ion. And you know that all these problems are pairs. They're the same atom. So you need to find where on the table these atoms are, this particular atom is. And of course, there's only one place it could be. And that has to be here. it has to be one of the members of group 4 because, of course, that's the only group that could be a plus or minus ion. So now we need to figure out which one it is. Well, for that, we would normally have looked at the neutral parent. Now we would see how many shells it has, and that would tell us the period, and we'd be able to select which atom from group 4 it was. But we don't have the neutral parent in this case, and I really wish that we did. So here's where that behavior comes into play that I've pointed out several times. Which of these two should we look at? Should we look at the negative ion to figure out what the neutral parent's like? Or should we look at the positive ion? Which one is more similar to the neutral parent? So look at the examples above, look at the examples at the very top of the page. What behavior did we find? Let me remind you. Cations lose the outer shell to form the ion. Anions fill the outer shell to form the ion. So this is going to give us the answer. So I don't have to draw it in, you don't have to draw it in, but I'm going to draw in the neutral parent because I really would like to see it. So here's the nucleus. I don't know what atom it is, and I need to figure out how many shells it has. So both the negative ion and the positive ion seem to have 3 shells, but we've seen how the positive ion has a different number of shells than the neutral parent. So what I'm going to do is I'm going to look at the negative version. The negative version has 3 shells, and that means that the neutral parent must have had 3 shells. I also know that it's in group 4, so there's 4 outermost electrons. So now I know the address of this atom on the periodic table. It's in period 3, group 4. So let me go and identify the atom. All right, so I'm in group 4, so let me get to period 3 now. 1, 2, 3. Here's the box that I intersect on. Let's see what that box is. Oh, that box is the silicon box. I now know the identity of my atom. This is silicon. This is silicon. This is silicon with a negative 4 charge. This is silicon with a positive 4 charge. So starting with silicon, the neutral parent, let me build both of those ions. The negative 4 ion results by the atom gaining 4 negatively charged electrons. That means it looks like this, 288. The positive ion has resulted by the atom losing 4 negative charges. That means it looks like this. And now I've diagrammed the 2 ions. So folks, do your best. See if you can finish the rest of them. Of course, all the answers are available, and you can always contact me, and I can give you any further help that you need. Good luck.